Let us begin with the topic of chemical kinetics. Now, before we go to the actual content of the chapter, let us try to understand what is the concept of chemical kinetics. If you take any chemical reaction basically has three aspects to it. The first aspect is the feasibility of the reaction. That is, whether a reaction would be possible or no. This is decided by the energetics of the reaction, which we studied in thermodynamics. Once feasibility is studied, the second important question arises: what is the extent of the reaction? For example, if I take 100 grams of reactants and I get 90 grams of product, so the extent of the reaction is 90%. Once extent of the reaction is known, the last and the most important point comes: what would be the time required to complete 90% of the reaction? Time is monitored as the speed of the reaction, and this is studied in the concept of kinetics. So kinetics is study of speed of chemical reactions. Now, when we talk about speed of a chemical reaction, it is denoted as a rate of reaction. And how is rate of reaction defined? As we all know, rate means some parameter studied with respect to time. Now, what can we study with respect to time? When you talk about chemical reactions, we can monitor what would be the change in concentrations of either reactants or product with respect to time. So what is rate of the reaction? The rate of the reaction is change in concentration of reactants or products with respect to time. Okay. Now let us take an example. Let's say at time equal to 0 minute. At time equal to 0 minute, initial concentration of a reactant A that is present is 5 molar. This is called as A naught. So A naught would be the initial concentration of reactant A in molarity at time equal to 0 minutes. Let's say at time 5 minutes. At time equal to 5 minutes, the reactant has reacted and the concentration has decreased to 4 molar. So the remaining concentration of A after 5 minutes is denoted as AT. So if we have to calculate the rate of the reaction would be a rate is equal to final concentration minus initial concentration, that is 4 minus 5 upon 5 minus 0, that is equal to so the change in concentration with respect to time, which is defined as rate, is equal to .2 molar per minute. Okay, now if you look at the values, the change in time is a fixed time interval. Therefore, the rate calculated is called as the average rate of reaction.